Okay, guys, so this is going to be your decorators and varsity functions lecture. So, should be noted, decorators are a little bit complicated. They're not bad, but there's a couple things you have to know first. So I'm going to go through three things we have to know first, and then I'm going to go through an understandable way to use a decorator, and then I'm going to go through what people actually do. And maybe I should start out with what a decorator is. So a decorator is the idea of making essentially a wrapper for a function that might give you some utility. Common things that people employ decorators for are things like putting timestamps on function calls. There are things like logging function calls. There are things like counting function calls. So any kind of thing that you want to keep track of for more than one function. Like I would like to keep track of how many times I call, say, these two functions in my program, or these 7 functions, or every function in my program, frankly. Or I want to know when this function's, or how long this function's taking to execute because it seems like my code's super slow. Or I want to know when my users are calling this function, so I'm logging it. All of those things are kind of valid ideas. The logging one is especially a handy thing if you have a big piece of code that keeps crashing and you don't know why. Especially like the Discord bot has hugely long uptime. But when it crashes, I often have this like, wait, what the heck happened right before it crashed? And so the log file is a nice way to do that. So to that end, the first thing we need to understand is that functions can be kind of renamed. Renamed is a bad word. So maybe let me say instead they can be aliased. You can call them something else if you want. So for this purpose, I just have an example function over here. I'm just going to copy and paste some code in here because I assume you guys are tired of watching me suck at typing. Okay, so here I'm just starting preliminary stuff. There's 3 of them. First thing is functions can be aliased, i.e. called by a different name. I'm going to print out the line functions can be aliased, and that's really just so I can keep this kind of output window organized for you so you can hopefully follow along better with what I'm doing. Here I'm defining an example function. Right. And so that example function is named example underscore function, right? Okay. So then we're going to print out, and this is all that function does, right? All this function does is print out this is the example function. And then here's a print line that's just, again, keeping track of what I'm doing. So this is just printing out that I'm going to call it, and then I'm going to call it. So if I hit run on this, I get, okay, this is my comment. The section I'm working on is functions can be aliased. We're calling this function, and then we get the result of the function call. Okay, now here's what it means to alias something. This means that we can just pick a new name, right? Example, xfunct, and we can just set that equal to example function. Okay, and you'll note I don't have the parens here. So the reason I don't have the parens here is I have to be really careful in this lecture especially about the difference between calling a function and the idea of a function. So when I don't have the parens, like this guy, when I have just the example function here, that's the idea of the example function. And in fact, if I throw a little diagnostic line in here just for a second, okay, so notice that the result of that print line, where I just printed out the example function, isn't the result of doing example function. See how it's function example function at a memory location? That's an object. So functions in Python are actually objects. what this means is that you can treat them like they're objects, which is fantastic. Like, this is why people love Python. Because you can do silly, stupid stuff, which is just great. Like, just make a new name for your function. And now, if I run this, it's not going to do anything, right? Because it's just assigning that label. But if I want to call it, and again, I'm copy and pasting a little code, so I just have a print line that I've copied and pasted. So if I want to call it, I get the exact same result, even though I called it by a different name. Okay, I know, this doesn't seem super useful, whatever, that's maybe a fair critique. Let me show you a keyword that I never use just because it's a thing. Del. Let's see if this, no, it's not going to tell me what del does. Okay, so the del keyword deletes from memory a thing. So I'm going to delete the example function. And then I'm going to call this thing again. Right, remember, it really is just another name for that thing. When I delete it and call it again, it really should be gone, right? But it's not. And this is part of the utility. You can permanently rename something, right? You can assign this thing to the new name, and then you can delete the old thing. Great. Why would you want to do this? Frankly, this is not a useful piece of information except to know that you can do it. So I promise this will come in handy later. For right now, I'm just going to remove this deleting because I don't really give a hoot if you know how to do that. This is literally the only time I ever use that keyword is during this lecture. Okay, so next thing's next. Okay, so that's what it means to alias functions. The next thing is that functions can be defined inside of functions. And I'm just, again, printing out a line. I'm including a carriage return just for formatting's sake. Okay. So let me define an outer function, right? And then inside of that outer function, I'm going to define an inner function. Okay, I know. Why would you do this, Joe? Trust me. It's actually very useful. It seems insane, but it is actually worth doing. There's another thing you can do with this kind of to make a poor man's switch that you can like use a dictionary or something. That's a little bit beyond the scope of today. Right now, I just want you to know that you can put a function in a function. So my inner function is just going to print out, this is the inner function. And I guess since I'm doing good naming scheme, maybe I'll just actually call it by its name. And then what we're going to do is we're going to print out, and actually let me just copy most of that. We're going to print out that this part is the outer function, right? You guys recognize that that's the outer function, right? So in my outer function, I made a function definition, and then I'm doing this printing out. That's the outer function. And then I'm going to call the inner function. Oops, if I could spell. Okay. So then I'm going to grab a print line here. And then we're actually going to call the outer function. Okay, so now if I hit run here, I get that when I call the outer function, it prints this is the outer function line, and then remember it calls the inner function and then does the result of that, right? So you can define a function in a function. I know, again, doesn't seem like something you would terrifically care to do. Like the first thing, right? So if you named it badly, just rename it, right? Duh. Why would you need a function in a function? That's crazy. Just define it outside and fine. Like, yeah, both of those critiques are perfectly reasonable. It's just how these things interact that become useful. Last thing last, functions can return functions. Okay, now this part seems a little crazy. So I'm going to define a greeting maker function. Okay, so my idea here is that I maybe have several, different language options. In my case, I really only am going to use two because I could only remember the word for welcome in two languages. But I'm going to define my greeting maker function, and it's going to take some text as an input. And then in there, we're going to define a function that's going to be our greeting, right? And our greeting function's not going to take any inputs. And what it's going to do is it's going to print out our text, which is going to be our customized welcome, and then something like comma space to the class. Right. This is just for flavor. This is not right. This isn't a translation function. It's really just a flavor thing. Okay, so I have my definition of my greeting function, right? And then I guess I should I'm going to throw a diagnostic line in here that we're going to print out that we're running the greeting maker. And then we're going to say return our greeting. Okay. Oops. Important point. I am not returning the greeting function run. I am returning the idea of the greeting function, right? So not the result of the greeting function, but the idea of it. And then what this is going to let me do is I can now make some new functions. So let me steal a couple lines here because this is a lot of typing. Okay, so we're going to print a line that says that we're making the greeting functions. And then we're going to make two greeting functions. They're going to be the German greeting and the English greeting, right? And they're going to be made by calling the greeting maker, right, which is my function, that returns a function. And we're going to call that on the string willkommen, which is German. I suppose that's obvious since I called it the German greeting. Okay, so the greeting maker is going to take willkommen, right? It's going to make that into a customized greeting function, and then it's going to feed that greeting function back. So the German greeting function is going to say willkommen to the class. The English greeting function is the same thing, but with welcome instead. Those are going to be distinct functions, right? One is stored in the German greeting variable, the other one's stored in the English greeting variable. Variable's a piss poor choice of word there because it's really a function, but a function is really an object, and an object instance is a variable, right? So whatever, or object name is a variable. I know, that was confusing. Sorry, my bad. So remember, German greeting is categorically a function, and a function is a kind of object. Okay, so now if I want to call them, then I actually need to run something like this, where I say, all right, I'm calling the greeting functions, and then I put the parentheses after them, right? That's as opposed to if I put the parentheses after them here, it won't even let me do this, frankly, right? Because it's saying, dude, you can't call a function and then assign that to something. Well, assign something to that, actually, right? A function calls a static thing, right? It's the result. It's not a variable. Okay, so now if I run this, I should see a couple. All right, so one, I see that the greeting maker function got run twice. You guys see that? That's this part here. That's running the greeting maker and running the greeting maker. That's on lines 46 and 47 over here, right? Those are the two calls into the greeting maker function. Okay, so then we call the two functions and we get willkommen to the class and welcome to the class. Okay, cool. So these are my three preliminary things, right? Functions can be aliased, functions can be defined inside of functions, and functions can return functions. Okay, now, to actually make a decorator. Okay, so this is the main idea. And this is the kind of first version understandable or more easily understandable wrapper. Okay, so the way this works is I'm going to make a function that I'm going to call add wrapper. Okay, and it's going to add wrapper to some function that gets passed to it. So I'm calling that function past function. Not past, but past. Hand it along. Right? So we're going to hand the add wrapper function a function, and what it's going to do is it's going to add a wrapper to it and then return it. Okay, so it's going to make a thing. So I'm going to, and this is the part, right, where I'm using can return a function. So, and also can assign a function in a function. Okay, fine. I use both words at the same time. All right, so I'm going to define wrapped function. Oops, typing's hard. See, this is why copy and pasting code is going to be a good idea. Okay, so the way we're going to define the wrapped function is first we're going to print out that we're running. And maybe actually let me add to this running the past function. Okay, now this is actually a really bad choice. This is bad phrasing. I'm going to come back and fix this in a minute. But right now we're saying we're running the past function. That past function's name is probably not past function. That would be real weird. So I really need to do something better with naming there. But for right now, I'm going to leave it, okay? All right, so we're just going to print that we're running the past function. And then in the middle, we're going to actually run the past function. Oops, that's not how you spell the word function. Why are you whining at me? Undefined name. Spell past function wrong? Oh, past function? No, past function. Okay, so we have passed our function, right? We're running the past function, we're calling it, right? And then we're going to print out that we're done. Okay, so that's what my wrapper does. My wrapper adds these two lines, one before, one after, that say I'm running this and I'm done, right? This is the easiest possible wrapper. Well, close to, right? It just tells you that something's running. So if the program hangs, you know which function was running when it stops. Okay, so good. One last thing. I need to get that wrapped function back. So I'm going to return the wrapped function. Now, notice I'm returning the idea of the wrapped function, not the wrapped function's execution. Does that make sense? So again, no parentheses here, because what I need is the idea of the wrapped function. Okay. Let's see. So I'm going to put a little comment here. So this thing is called a decorator. And the reason it's called the decorator is, or a decorator, right, is that what it does is it takes a function that already exists and it decorates it with some stuff that you wanted. So in this case, it decorates it with status updates. It could decorate it with runtime updates. It could decorate it with logging. It could decorate it with whatever the heck you want, the username of the person who's running it, right? It could decorate with any number of things, all of which would probably be useful. Okay. And please note, you can decorate shit that you don't own, which is kind of nice. right? So you don't have to define the function. You don't have to define the past function, right? You can just push it along. So here I'm going to define the function that I'm going to wrap. And I'm going to define a function called function, which I know I ran out of example words earlier. Okay, so I'm going to define a function, and all it's going to do is print out sum, right? Okay, so now let me go through this a little bit. First things first, I'm going to steal a print line. I'm going to run this function without the wrapper. So let me see that. Okay, so I have my print line that says this is the part where we talk about understandable wrappers. We're running the function without the wrapper. All we get is this printed sum. Okay, cool. Okay, so let's do another thing. Oh, I copy and pasted too many lines. Or I copied too many lines. I didn't want to spoil the surprise. All right, so I'm going to wrap the function. Now, the way I'm going to wrap the function is I'm going to do something a little bit weird. I'm going to say f is the function, right? So this would just be an aliasing. But I want to wrap it, so I'm going to call the add wrapper function on the function. Oh, and actually that wasn't going to work anyways. So sorry, hang on, let me go back just one. When I had this just a second ago and I said that was going to alias, that wasn't going to alias, that was going to get f garbage, right? F was going to be none, which is what the function returns, right? There's no return here. So this is an alias now, f equals function. That's just aliasing. So I don't want to just alias, I want to wrap it. So I'm going to call add wrapper on the function. Okay, so now if I run this, what do I expect to see? I expect to see exactly the same thing, except this line about wrapping the function. I don't expect to see the wrapped function run because I never called it, right? So if I want to call the wrapped function, I need to take its name. So what's the name of the wrapped function? Yeah, it's f. Not function, it's f. Okay, so now if I hit run, I get running the past function, sup, done, right? You guys see that? Okay, so this is now, f is decorated. Now you can say, you know what, I don't really like this using up a new variable, so I'm just going to stick it back in the same variable. Right, I'm just going to call it function again. See, it acts exactly the same. That's, remember, you can delete the old one. Same thing here, right? So this is just updating a variable in place, right? So this is taking the function, right? And in the memory, it's just overwriting it with the wrapped version. Okay, so now it's permanently wrapped. Okay, cool. If you needed the old version for something, maybe you wouldn't do this. Actually, frankly, you wouldn't do this anyway because this isn't how people do decorators. Okay, so here's the way people actually do decorators. Okay, I'm going to steal a couple lines out of my previous work here. All right, so now for the way people actually use it. So this is what I'd call decorator style. The other one is kind of like naively wrapping things. I don't mean that badly. I just mean that it's like the first thing you would try. Decorators are just a touch cooler than that. Like they're edgy or whatever. So in the decorator style, right, you define a function with a decorator. And the way you do that is you just type one line above the function definition at and then the name of the decorator you want. So I want to call the add wrapper decorator, right? That's this guy up here. And I don't even need to tell it what I'm going to pass it because the thing I'm going to pass it is a function. So I'm going to call add wrapper. Why is it whining? Oh, it's whining because I haven't finished the fun. And I want to define a decorated function, right? And my decorated function is just going to be a function that prints out this is decorated, period. Okay, so that's just defining it. Now if I actually want to call it, then I need some kind of a line like this one, where we print out, we're running the decorated function, and then we actually do so. And now I see that in the decorated style, right, I just put this at keyword here, and now it goes ahead and defines this thing. Okay, so I'm assuming that this seems awesome because it is. So the thing you're probably wondering is, Joe, are you a moron? Yes, I am a moron. And also, you think I'm a moron because you usually pass shit around in functions, and it doesn't seem like that would work here, right? Totally reasonable, but we learned a thing that lets you pass shit along without knowing exactly what it's going to be, right? Remember the args and quargs things? So, if you want to say, look, when I call decorated function, I'm going to pass some stuff along with that. When I decorated that function, I called the add wrapper, right? So if we go look at the add wrapper, this is the part where the wrapped version of the function is defined. And I'm just going to tell it that it can expect some arguments and some quarguments. I know that's not actually how you pronounce that, it's just fun. Okay, so, oops. And traditionally this is spelled args and quargs. Please note that's only tradition, they're just names. It doesn't actually matter. The thing that matters is the asterisks. Asterisks, astrici, asterisks, the little stars. How about that? Okay, and so the little stars are going to be expected to be passed along to the wrapped function, and then if you want to pass them along to the passed function, you put them in here. Now this is going to run exactly the same way. If I wanted to tell my decorated function to expect a number, and I wanted to print this is decorated and my number, and I wanted to call this with say 9. Now what's going to happen is it's going to add that expect some arguments to the wrapper. It's going to pass those arguments just straight through, and so I should see, there we go. This is decorated, and then I got my 9 there. So it very happily passed the arguments along. It's no big deal. You can actually just always include these with your decorators. It's probably good practice. It might be nice if you knew what to expect there, but this is actually a little bit safer. So next, this past function business. I'm going to make here a formatted string, right? And instead of, sorry, this was about the name, right? The function that I was passing, it wasn't called past function, it had its own name, right? So what I'm going to do is I'm going to take past function and, oh, it's not going to lint me, it's not going to help me. If you do this in VS Code, it'll tell you that this is a function that it has some properties. One of those properties, here we go, is a name. So underscore underscore name underscore underscore, and that is literally just the function's name, right? It's like whatever it's called. Oh, interestingly, I don't know how that acts with aliases. We could check. Okay, so now when I say I'm running the function, sorry, wrapping. Okay, so I'm looking for my, I'm looking for my add wrapper calls, right? So my add wrapper calls got, let's see, understandable wrapper. I'm running the function without the wrapper. Okay, that's not this. I'm wrapping the function, also not. Then I'm running, comma, the, and then this should be past function dot name, which in this case is function is its name. When I see the other one, right, that's down here, running, this is the decorated function, that is that function's name, right? So you can get the name of the thing to be accessible to you, and if you want to pass arguments along, you use the args and quarks. I hope this is comprehensible. This thing is just a little bit complicated. I'm going to give you some exercises to try to help you understand how this works. And the first one, I think I'll just have you comment a bunch of, I'm going to have you comment a piece of code that already includes a decorator, just to see if you can understand what it's doing. Maybe make some minor changes. Okay, so I left that off like I was done, and as it turns out, I forgot to add a couple of things. One is if you want to add a decorator to a function that you've like taken out of a library or something, let me show you how to do that. So I'm going to violate convention a little bit here, and I'm just going to import the randint function down here at the bottom, which is crappy form, I know, but so this is for adding to existing functions and dealing with returns. Okay, so if I want to add a wrapper to an existing function, like the randint function, one way for me to do, probably the best way for me to do that is to just overwrite it in the namespace. So that's just to add the wrapper to it and then re-alias it back to itself. So I'm going to do randint equals add wrapper, right, to the randint function. Okay, now when I run this, I get all the other stuff, and then I don't get anything out of the end here because I haven't run anything, right? Oops, that's, let me just, all right, so I'm going to add this little header down here just to separate from everything else. So now I should get a print line. Okay, good. So that's just going to be adding to existing functions. We got an existing function, right, from the random library. We added the wrapper to it, right? So I'm still using that add wrapper. So that's this line roughly. I am wrapping the randint function. Okay. Then I should probably call it. So I'm running randint. Oops. I'm running randint, but I didn't actually do that. And remember, randint takes a couple of numbers, like 1 and 3, right? And it's telling me that I'm not adding any keywords, but it's running. Okay, cool. So the thing is, it's not printing anything, right? And the reason it's not printing anything is the randint function itself doesn't print anything, right? It just gets a random number between 1 and 3 and returns it. Okay, so I wanted to print something. So I'm going to throw a print around here. you'll see that it is running and done. So the wrapper is working, right? It's just not printing any result from that randint call. And now it is, but it says that the result from the randint call is none. And the reason for that is that my wrapper's not designed to preserve the return. So when I go up to my wrapped function, right, this is my wrapped function definition, it prints that it's running the past function, and then the past function is called, and then it prints that it's done, but there's no return from this thing. So even though the past function returns something, this thing doesn't save it. See that? So if I wanted to save it, I'd save it as something like maybe called result, right? And then I'm going to return the result. And now when I run this, I should get 3. And you'll notice it didn't affect anything else because the other things didn't return anything. And so the wrapped function just returned none because the result was none, right? That's actually why that variable type exists in Python. It's actually the thing that you have problems with in other languages is that functions don't have a default return type. You have to specify something. In Python, they all return none unless you tell them otherwise. So in this case, I think I've got this working. If I call it again, okay, and I'm noticing that my grammar's a little bit off. Probably that would be good to fix in a future update, but I'm not going to fix it now. All right, hope that helps. I am done this time, probably. We'll see.